propulsion system has no moving parts. Nothing spins. Nothing rotates. And somehow, it still moves. That's the idea behind magnetohydrodynamic propulsion, often called MHD. Instead of using propellers or turbines, MHD systems try to generate thrust using magnetic fields and electrically charged fluids, which sounds simple until you realize what that actually means. To make this work, you first need a conductive fluid, something that can carry an electrical charge. In many concepts, that fluid is seawater. When an electric current passes through that water and a magnetic field is applied at the same time, something interesting happens. The fluid itself experiences a force. This is known as the Lorentz force. Instead of pushing against a propeller, the system pushes directly against the fluid, and the fluid pushes the vehicle forward. No blades, no gears, just fields and flow. But here's where things start getting weird, because if nothing is spinning, what's actually doing the work? The answer is energy. A lot of it. And this is the wait, what moment. MHD systems don't remove mechanical complexity. They replace it with electrical demand. To generate enough force to move a vehicle through water, the system needs extremely high electrical currents and strong magnetic fields, which means massive power requirements, which means heat, a lot of heat. And unlike traditional engines, you don't have spinning parts to distribute or manage that energy in familiar ways. Everything is happening inside fields you can't see. Now add efficiency to the problem. Water isn't a perfect conductor. Energy gets lost, converted into heat instead of motion. So while the concept works in principle, scaling it becomes difficult. You can build a system that moves, but building one that moves efficiently, that's a different challenge. There's also control. Traditional propulsion systems rely on mechanical components that engineers have refined for decades. MHD systems rely on invisible forces, which makes precision harder. And then there's the environment. Salt water helps conductivity. Fresh water reduces it. Different conditions change performance. So now the system isn't just fighting physics, it's reacting to its surroundings in ways that aren't always predictable. And yet the appeal is obvious. No moving parts means less mechanical wear, less noise. Potentially quieter operation, especially important for underwater systems. That's why MHD propulsion has been explored for naval applications, including experimental submarines. Because a propulsion system with no moving parts is also a propulsion system that's harder to detect, but the trade-off remains. Energy, heat, efficiency. Magnetohydrodynamic drives don't break the rules of physics. They just approach them from a completely different angle. Instead of spinning something to push against the environment, they turn the environment itself into the engine. And when you start using invisible forces to move massive objects, it stops looking like engineering and starts looking like something else entirely.